To the friends of courses in the cement industry, I hope to subscribe to the membership, so that we can continue to provide useful content. In this course we will detailed explanation. Grinding training session. Ball mill dynamics. Grinding. Course 1. Brief about mill compartment. The first compartment, lined with lifter plates, is for coarse grinding and therefore has a charge of large balls. The second compartment has a classifying plate lining, and a charge of smaller balls for fine grinding. Adjustable lifter scoops in the intermediate diaphragm ensure an optimum flow of material, from the first compartment into the second compartment. Watch this video that shows the tube mill, ball mill. Watch this video that shows the components of the mill from the inside. This course content. 1. Size reduction mechanism. 2. Release point and internal dynamics, first and second chamber. 3. First chamber liners. 4. Second chamber liners. 5. Fastening types. 6. Balls. 7. Mill head liners. 8. Material transport. One. Size reduction mechanism. 3 mechanisms of size reduction. 1. Fractures. Crushing. 2. Chipping. Crushing and some fines. 3. Abrasion. Fine grinding. Ball mill operating principle. A ball mill is a type of grinder, used to grind using different sized balls. The working principle is simple. Impact. Attrition. Size reduction, take place as the ball drops from near the top of a rotating hollow cylindrical shell. This figure also shows. The ball mill operating principle is simple. 1. Impact. 2. Attrition. Ball mill. We can divide the ball mill into 2 parts. First compartment, crushing, where there are grinding balls of large sizes. Chamber 1. Second compartment, grinding, where there are grinding balls of small sizes. Chamber 2. Feeding. This figure shows internal ball dynamics. 1. Balls cataracting. Free fall of the balls. Emphasis on crushing. 2. Balls cascading. Tumbles along charge surface. Emphasis on fine grinding. Important note. Internal dynamics depends on the release point. Two. Release point and internal dynamics. First and second chamber. Release points and grinding. Position depends on two main factors. 1. Percent of critical speed. 2. Liner's design. This figure shows 1. Cascading, tumbling. 2. Cataracting, free fall and max impact. 3. Excessive lift, impact on liner. We follow together. Ball mill dynamics. 2. Release point and mill critical speed. 1. Speed of rotation at which centrifugal forces overcome gravity forces. At that speed, the balls no longer fall, or cascade but ride on the liners around a full revolution. N equals 2. The best grinding efficiency is reached at 75% of the critical speed. N equals 3. Mill speed is usually between 70 to 78% of NC. See this animation about ball mill critical speed. We follow together. Ball mill dynamics. 2. Release point and mill critical speed. Different liners design can give different release points, and therefore different grinding actions. We follow together. Ball mill dynamics. 2. Release point and mill critical speed. Internal dynamics in first chamber. 1. Primary grinding of coarse material with large grinding media, A90 to 60 mm. 2. Aim, high activation of the ball charge for crushing action. 3. Good efficiency criteria. Before intermediate diaphragm. 1. 5% of rejects at 2.5 mm. 2. 15 to 25% of rejects at 0.5 mm. We follow together. Ball mill dynamics. 2. Release point and mill critical speed. Internal dynamics in first chamber. 1. Development of a high fineness with small grinding media, diameter 50 to 15 mm. 2. Aim, attrition, and pressure grinding. 3. Good efficiency criteria. Before discharge diaphragm. 1. 5% of rejects at 0.5 mm. 2. 20 to 30% of rejects at 0.2 mm. We follow together. Ball mill dynamics. 3. First chamber liners. Purpose of a liner's design. 1. Each liner is designed to ensure a. Lowest specific energy consumption. b. Highest production capacity for a shell design. 2. Protect mill shell and ensure efficient grinding action. 3. With lowest possible specific cost for liners. We follow together. First chamber liners. This figure and animation shows. Grinding in ball mills takes place by lifting the grinding media charge, and the material to be ground followed by a return to the bottom part of the mill tube, in this continuous cascading movement. The material quality of the wear parts in a ball mill must therefore partly be resistant to overhammering without cracking, and partly withstand abrasive wear. We follow together. First chamber liners. Many different types of first chamber liners in ball mills. 1. Wave liner type, duo lift. 2. Activator liners. 3. Step liner type, X lift. 4. Step liner. 5. Step liner, with wave profile. We follow together. First chamber liners. This figure shows step liner. In addition to the material quality for the lining, the shape and the surface also influences wear in ball mills. Sliding motion between the ball mill liners and the charge of grinding media and material is, to a very great extent, responsible for wear on lining plates on the mill shell. The lining plates should be designed to ensure a minimum of sliding movement, and at the same time, the profile of the linings should lift the charge of grinding media sufficiently to transfer a high power uptake while maintaining the impact forces at an acceptable level. We follow together. First chamber liners. This figure shows step liner. Specification step liner. 1. Only for first compartments. 2. Better wear characteristics. 3. Moderate lift. 4. Designed for DIN drilled shell. We follow together. First chamber liners. This figure shows single wave, dual lift, liners. Specification single wave liners. 1. Only for first compartments. 2. Single wave. A. Negative backslope induces sliding. B. Racing is common, where life is short. C. It has good lift. 3. Dual lift. A. Has a small hump in between lifts to prevent racing. B. Liner a Euro trademark S life is much better. We follow together. First chamber liners. Installed dual lift liners. When lining plates in ball mills are to be installed, they must be supported in such a manner that major bending stresses are avoided when the bolts are tightened, since such stresses will often result in fractures. It is therefore essential to ensure that the contact faces of the lining parts around the bolt holes lie directly against the support. This is especially important for the relatively thin lining parts and grates in chamber 2 of cement mills. The fastening bolts for the lining plates must be tightened to the specified torque level and retightened after the start of the mill until the torque remains constant. Note: any superfluous bolt holes in the mill shell, heads, trarnions or slide rings, must be closed with glued-in rubber plugs. The holes should never be closed by welding. We follow together. First chamber liners. First chamber reminders. A. Be careful of the appropriate ratio between 1. Critical speed. 2. Liner lifting action. 3. Ball filling rate. 4. Ball size. Note: risk of broken liners or high wear level. B. Liners must be changed when 60% of their effective lifting height has worn away. Note: also if no change linera. Consequence 8 to 10% production loss. Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information by subscribe to the membership and inviting your colleagues to watch this channel.